Now, till now we were seeing that is the reaction of aldehydes and ketones with dilute alkalis. Now, what happens when aldehydes and ketones reacts with concentrated alkalis? Alright. Now, when it reacts with concentrated alkalis, it undergoes two types of reactions. One is resinification, another is Cannizzarose reaction. Let me tell you, ketones neither undergoes resinification nor it undergoes Cannizzarose reaction. Ketones. Why? Because for Cannizzarose reaction you will study, that is there should not be any alpha hydrogen atom present in the compound. There should not be any alpha hydrogen atom. In the aldol condensation I said there should be an alpha hydrogen atom. But in Cannizzarose reaction, alpha hydrogen atom should not be there. Ketones contains alpha hydrogen atom. So hence ketones does not undergo Cannizzarose reaction. Okay, fine. Then why not it undergoes resinification with concentrated alkalis? Alright, why not it undergoes resinification, ketones with concentrated alkalis? The thing is that resinification is nothing but repeated aldol condensation, you can say that. Repeated aldol condensation. And as ketones are less reactive in nature compared to aldehydes, so hence it does not undergo repeated aldol condensation. Alright, that is repeated aldol condensation means it will form aldol, then water will be released, again it will react, again it will form another aldol, again water will be released. In this way it goes on till it forms a brown resinous mass. Resinous means oily like, we can say that, which floats. A brown colored mass will be there which will be floating in a liquid, that is called as a resinous mass. Oily like substance will be there, a spherical brown mass you will see, it will be floating in a particular liquid, that is, let us say water, we can say that is called as a resinous mass. It's said to be resins, that is known as. Alright, so here that is water will not be there, here NaOH will be there. Alright, concentrated alkali I will be taking it, that is NaOH, KOH will be there, so it will be floating there, a brown colored, alright, mass we can say, which will be oily type, we can say that. Clear? So this it does not form. Why? Because again let me say you that ketones are less reactive in nature. So hence repeated aldol condensation it does not take place. It does not take place, we can say that. So hence it does not. So hence what we find is that it does not undergo neither Cannizzarose reaction nor it undergoes resinification. So this is the difference between aldehydes and ketones. Earlier also I have said you many differences. Alright, so ketones neither undergo resinification nor Cannizzarose. You may note it down, this particular one. Now, what is resinification? Already I have said you that for resinification, alpha hydrogen atom must be there. For Cannizzarose, alpha hydrogen atom is not required. That is the next time going to come. But for resinification, alpha hydrogen atom must be there. It is a repeated aldol condensation. The difference is there the reaction is taking place in presence of dilute NaOH. Here the reaction is taking place in presence of NaOH, that is concentrated NaOH. So hence repeatedly the reaction goes on repeatedly. The reaction is being carried out, we can say that. And here the first step is with concentrated alkali, so where you get a condensed product. Then after that the second step not with diluted cell, simply heating will do. Simply heating will do, because the condensed product which will be formed, it will be unstable in nature. It will be unstable in nature. For that purpose, on simply heating, water is released and you get a particular product. Again it reacts with what you can say concentrated alkali and another aldehyde, we can say that. Clear? Another molecule of aldehyde, same aldehyde, another molecule of aldehyde, and again it forms a condensed product. Again it is unstable, again it releases water, and again. So in this way the chain reaction goes on. And finally we get a resinous mass. I said what is a resinous mass it is. Now let me write the reactions, you will come to know. There is CH3 CHO, just like I wrote it in aldol, same sort of. Here it is also CH3 CHO, we can say that. So this H atom goes here. Here it will be NaOH. NaOH I will take, but it should be concentrated alkali. For that reason, the condensed product which is being formed, it is unstable in nature. It is not stable, it is unstable in nature. So that will be CH3CHOH and CH2 and CHO. Alright, the product is unstable in nature. What is the condensed product? Now the question you can ask me that why it is unstable. In case of dilute alkali it is being stable. In case of concentrated why it is unstable. The answer is here only. Because in case of dilute alkali, what I said dilute means more of water is there. Concentrated means less of water is there. Got it? That's the point number one. Now what is that? Water acts as a polar solvent. So it stabilizes the substance. It acts as a polar solvent. It stabilizes the substance. Stabilizes means the ions remains far apart from each other. You have studied in class 11 the Fajan's rule. Alright, the ions remains far apart from each other and the ions does not come near to each other. So it remains far apart from each other. Alright, clear? In case of what? In case of polar solvent. Alright, so as a result, what happens is that they do not, undergo again further reactions. But in case of concentrated alkali, what you find is that NaOH, the ions, they come closer to each other. And hence, they can form some other product. For that reason, I said that repeated reaction is going to take place. Because the ions, what I am saying, they come closer to each other. And hence, they form repeated, but you can say reactions. But in case of dilute, as a polar solvent, so hence the ions, they remain far apart from each other. Because it is a polar solvent. And hence, once the product is being formed, unless and until you heat it, for that reason I use a word, unless and until you heat it, dilute HCl, no further reaction is going to take place. But here it is going to form, because here the product formed is unstable in nature. Got it? The reason why it is unstable, because here the substance is concentrated NaOH, due to which I don't say it is non-polar in nature, not at all, I don't say that. But as the water content is less, so for that particular purpose, the polarity is also being less, and hence the molecules, they come closer, and closer means again it will form another reactions, again it will form another reactions. In this way, still it attains stability, the reaction is being carried out. So here what will happen, I will be heating it, this one simply heating it. On heating, what I will be getting, CH3CH, double bond CH, single bond CHO, single bond CHO. Again it will react with NaOH concentrated with another alkali, with another aldehyde, CH3CHO, with another aldehyde. And here also I can write it in this way, that is CH3CHO, I can write it this way. Now this goes here, again it comes here. Alright, and what is the product you will be getting it? You can understand it. What is the product I will be getting it? Clear? When it reacts with this particular, this is this is the product I have written it. It should be in the, let me rub it. I forgot to put the plus sign. Instead of that, I put the arrow mark. You can see plus, here it will be CH3CHO. Yeah. Then after that I should put dilute, that is NaOH, concentrated NaOH concentrated. Alright. So what is going to happen? This H now will come here. So when this H comes here, it will be CH3, then COH, then here H, here it will be H, here it will be, that is nothing but CH, double bond CH, single bond CH. Again this water will be released upon heating. So what I will be getting here, when water is released, you can see, you can write here minus H2O. Here also, and let me write here minus H2O. What is there left? It is CH3, CH, again double bond CH, again CH, again double bond CH, single bond CH. In this way, again the reaction will continue. Again it will continue. So in this way, till it forms a resinous mass, it will continue. This is called as resinification. It reacts in presence of concentrated NaOH. But ketones does not undergo this particular reaction, so to say. I hope you understood what is resinification. Now, next, after that we'll come to Cannizzarose reaction. Now, the condition in Cannizzarose reaction already I said you. In case of Cannizzarose reaction, alpha hydrogen atom is not required. So the condition is the compound should not have any alpha hydrogen atom present in it. Alright, the first condition. And the second condition is that the reaction takes place in presence of concentrated alkali. The reaction takes place in presence of concentrated alkali. Alright, and alpha hydrogen atom is not required. That means formaldehyde and benzaldehyde will undergo this sort of reaction. Formaldehyde and benzaldehyde. Here also we are having crossed Cannizzarose reaction and simple Cannizzarose reaction. Alright, what I said, cross Cannizzarose and simple Cannizzarose reaction. Fine. Simple Cannizzarose reaction means both the aldehydes should be of the same type. Like formaldehyde, benzaldehyde, in this way. Same type, we can say that. That is simple Cannizzarose reaction. Now in Cannizzarose reaction, what happens is that one more thing you need to know is that it is an auto or self-oxidation reduction reaction. self-oxidation reduction reaction. That means one of the aldehyde is oxidized and other is reduced. One of the aldehyde is oxidized, so aldehyde is oxidized to form acid, and when aldehyde is reduced, it forms alcohol. That particular acid reacts with NaOH. I have taken concentrated NaOH. It will react with NaOH to form salt, and water will be getting it. Okay, again I repeat, in Cannizzaro reaction, the main condition is that there should not be any alpha hydrogen atom. I don't want any alpha hydrogen atom. And the reaction takes place in presence of concentrated alkali, like concentrated NaOH, KOH, K2CO3, Na2CO3, all this sort of, we can say concentrated, we can say that. And it is a self-oxidation reduction reaction, got it, in which one of the reactant is converted, is oxidized, another reactant is being reduced, we can say that. Clear? Let me write the reactions, then you will come to know. So let me take here, that is formaldehyde, because I said formaldehyde and benzaldehyde undergoes this reaction. So it is HCHO plus HCHO in presence of NaOH conc. Now what will happen? One is going to get reduced, let us say. This is reduced. Anything, you can also say this is reduced, any one, because both are same now. So when aldehyde is reduced, what do we get? Alcohol, CH3OH. When aldehyde is oxidized, what we get? We get acid, HCOOH. This will give you CH3OH, and this will give you formic acid. Formic acid reacts with NaOH because acid and base cannot remain together. It will react to form, what is that? HCOONA plus water. Salt and water, you will be getting it. So ultimately, you got it. There is nothing but CH3OH plus HCOONA. But this water is being dissolved here because you balance it. You can see here how many carbon here. Here 2 carbon, 2 carbon. 1, 2, 3, 4 hydrogen. Here 3, 4 and 5 hydrogen. You will be getting it. Now from where we are getting it? See here. So here that is 5 hydrogen. Here you see 1, 2, 3, 4. Another hydrogen here. This one 5 hydrogen. Now oxygen here 3 oxygen. Here it is 2 and 1 3 oxygen. 1 sodium, 1 sodium. What is being left? No, nothing. So in this way it is being balanced. So hence water is not being formed basically here. Clear. But theoretically you know that salt and water is being formed here. We know that. Clear. When acid and base reacts, we can say that. Clear. So in this way, this is on a self-oxidation reduction reaction. This is on a simple Cannizzaro reaction where both the reactant are the same. Suppose if it is different, like one is formaldehyde and another is benzaldehyde. One is formaldehyde, another is benzaldehyde. Okay, this is benzaldehyde in presence of NaOH comp. Now, which is going to get reduced and which is going to get oxidized? Remember it. The one which has the lesser number of carbon atom is going to get oxidized. This one, always remember it. The one which has got lesser number of carbon atom, it always get oxidized first. Got it? Having lesser number of carbon atom because it is more reactive. Clear? So hence this will get oxidized and this will get reduced. So reduced means it is going to form, that is benzene ring CH2OH, benzyl alcohol. And this will get oxidized to form acid, HCOH reacts with NaOH to form HCOONA. Because here there is no confusion. Anyone you can reduce and anyone you can oxidize it. But when there is two products, two different products, then there is a confusion that which one I should take for oxidation, which one I should take for reduction. Alright, so that you must remember it. Okay, so this is your Cannizzaro reaction. CANNIZZARO apostrophe S. CANNIZZARO apostrophe S. Cannizzaro reaction, so to say. Next we'll come to Tischenko reaction. Tischenko reaction. We can say that. Now, Tischenko reaction is a modified form of Cannizzaro reaction. It's a modified form of. It is given by all aldehydes and ketones. Why it is form modified form? Because in Cannizzaro reaction, what you require? Alpha hydrogen atom is not required. And in reaction takes place in presence of concentrated NaOH. Here alpha hydrogen atom whether it is there or not there, no matter. Whether in what you can say in Cannizzaro ketones does not participate. Here ketones also can participate and the reaction can be carried out. So hence it is a modified form of what you can say that is Cannizzaro reaction, so to say. That is a Tischenko reaction, we can say that. So here what will I do? Let me take here that is CH3CHO. plus CH3CHO. Same thing. Let me take it here. In presence of, I will be taking here a different one, not dilute NaOH, KOH or concentrated ATs. Here we will be taking aluminium ethoxide, that is AlOC2H5 whole thrice. Alright, now what is going to happen? Same thing, self-oxidation reduction reaction is going to happen. One, it is going to get oxidized, other reduced. So CH3CHO will oxidize, aldehyde will oxidize to acid, that is CH3COOH, and this will be reduced to alcohol, that is nothing but C2H5OH. See, CH3CHO, this one aldehyde will be oxidized to acid. You got acid. This will be reduced to alcohol. You got alcohol. Now you know, like acid and base reacts to form salt and water. Similarly, acid and alcohol undergoes esterification reaction. Always remember that. They undergo esterification reaction. Alright, so hence it is going to form ester, CH3COO C2H5. CH3COO C2H5, and HOH is removed. This water is removed, minus H2O, and it forms ethyl acetate. We can say that. It forms ethyl acetate. We can say. So in this way, you can take another, that is, I have taken two acetaldehyde. You can take acetaldehyde and acetone, and we can carry it out. Alright, or we can take two acetone and we can carry it out. Or we can take another ketone also can be taken. Got it? And we can carry it out in this way. So in this way, any reactions can be done with what you can say Tischenko reaction. So it is a modified form of Cannizzaro reaction, is said to be as. But let me tell you here, with ketones, the reaction is very, what you can say, slow. That also let me tell you. With ketones, the reaction is very, slow. With aldehydes, it is fast. Already I have said you why aldehydes are more reactive than ketones. With ketones, the reaction is very, slow. So hence, apart from, that is aluminum ethoxide, you have to take a catalyst here. Alright, you have to take a catalyst here. That is either nickel, platinum or palladium. You have to take a catalyst and you have to heat it, not hydrogen, of course. So then only the reaction can be carried out. So in certain cases, we say that Tischenko reaction does not take place in ketones. Alright, that also is true. If you take only aluminum ethoxide, then it is not going to take place, because you have to take that catalyst, otherwise the reaction will be very, slow. Alright, this also I am adding it here. This particular statement, you should understand it. Now, reaction with phosphorus pentachloride, PCl5. So, CH3CHO plus PCl5. You know, I have said you already that when any reactant reacts with PCl5, the compulsory product is POCl3 and HCl. So POCl3 will be formed, definitely, POCl3. But HCl will not be formed, because that HCl again will react with this aldehyde to form a, that is, product, we can say that. How it is going to form? See here, CH3, then CH, and this oxygen will be replaced by 2 chlorine, because 2 chlorine, here Cl3, here Cl5. So 2 more chlorine is there. So it is in this way, it is being forming. CH3, that is CH, and Cl, you will be getting it. Clear? So this is the product, you will be getting it here. So in this way, this product you will be getting it. Oxygen goes here, so there is no doubt, and hence we got this particular product. This is called as ethylidene chloride. This is known as ethylidene chloride. Clear? Ethylidene, this is known as. You can do the same reaction with ketone also. The only difference is that in ketone CH3, and here you will be getting CH3. Finished. These are difference. Now, what is the name of this product? It is known as 2,2-dichloro 1,2,3. So 2,2-dichloropropane. That's it. With acetone, you will be getting 2,2-dichloropropane. That's it. Very simple it is. Alright. So, next is with chloroform. We will see the reactions. So, now with chloroform, this was with PCl5 we got it. Now we will see the reaction with chloroform. So with chloroform, what is the reaction is taking place? Let us see. Now, next is here, ketones condense with chloroform in presence of potassium hydroxide in order to form chlorohydroxy compounds, we can say that. Clear? So, like acetone, let us say. Ketones means, it does not mean acetone only, it can be any ketone. Alright, let us say that, what I said here, ketones condense with chloroform in presence of potassium hydroxide to form chlorohydroxy compounds it is going to form. Then let us say in terms of ketone, let us say, let me take acetone. Alright, let me take acetone. What is going to happen? See here. CH3CO CH3 plus CHCl3 in presence of KOH. I already said it. Alright, clear. So what is going to happen? See, it is a very simple product. CH3, here CH3, here it will be OH, and here it will be CCl3. This is known as chloroetone. Chloroetone, CHLORETONE, CHLORETONE, which is used as hypnotic. Hypnotic means sleeping pills. It is used as sleeping pills, this particular one. But aldehydes do not undergo this particular reactions. Aldehydes. Why it is so? Aldehydes is more reactive than ketones. Why it will not do? Because what I find is that here, in presence of this particular KOH, aldehydes will undergo aldol condensation. Condensation reaction is going to undergo. It is going to undergo, and hence you will get a different product which we have already seen it. This particular one. A condensed product means chloroform will no more will be used. Two molecules of aldehyde in presence of KOH will be forming a different product. That is the aldol condensation product. You will be getting it. So there is no role of chloroform here in that particular case. Clear? So hence aldehydes do not undergo this type of reaction. But ketones has undergone. That is what I mean to say. Ketones undergoes, because ketones does not undergo that particular reactions. Alright, we have seen it already. So now next is we will see the reaction is Skipp's reagent and all. So Skipp's reagent, what you find is that Skipp's reagent, if you take aldehyde and Skipp's reagent, which is colorless, it becomes pink color. Skipp's reagent is the reagent which we do the test, we can say that. So aldehyde when reacts with Skipp's reagent, it gives you a pink color. But ketones does not have any reaction. Acetone, however, restores the colors of Skipp's reagent, but very slowly, we can say that. Clear? Okay, this is the reactions, we can say that.